we have to continue with chapter 8, the last part in coding theory about the group codes. Yeah, about group codes. So I give you the definition of a group code. In my notes, it's the 5th definition, okay, of this. What, I don't have to write it again. What is a group code? And MN encoding function. Okay, why is it called MN? Because we want to have this function from M to N. Okay, this is called a group code if, okay, f of Bm, you see, f of Bm gives us all the images, right? F of B, in which B in, okay, f of Bm is f of B in which B is from Bm. So if you look at from Bm to Bn, and there is an f. So if you have B in Bm, B in Bm, f will give you fb. You see how explanation is easy to understand by graphically, right? Okay. This is what we call is the range of f. We call it n if this is a subgroup of B. You see this? This one is the range, yeah? You know function means? Function means every element in here has to have an image, right? That is the definition of a function. And from there, you can get what we call n, the range, right? What we call n. Some of, if it's not on 2, some of the elements in Bn is not mapped, right? It's not an image, right? And all of these go to only this. And if this n is a subgroup, if this n is a subgroup of Bn, then we call that this encoding function f is a group code. Okay, so this goes back to the last chapter, right? For the group one, the algebraic structures and group. And we recall what does it mean by a subgroup. Okay, so I put there. You remember group we have close, associative, identity, inverse. Yeah, to be a subgroup, we don't need to check the associativity. You remember in that class I said because a subgroup is a subset, right? A subgroup in the first place is a subset. So if G is associative, H is also associative. So we just check whether E of the group G, is it in H, right? Is it close? If you take 2 elements in H, is it the product or the what we call the multiplication is in H or outside, right? Close, the identity, and the inverse. Is the inverse of element in H go back in H? So we have to check these 3 things. Okay. Let me put that down. So we Remember this. Okay, so the first one, the identity of Bn, this is the EG, right? EG. Our G, Bm to Bn. Okay. This is M, yeah, Shiham? Because we want the identity of G inside here, right? We want this, the identity of Bm, okay, is in N. Wait, sorry. Okay, you're confused. Now this is here. Okay. Okay, this is our N, not this one. Okay, this is H. This is our H. And G is Bn, yeah? This part. Okay, we want to look at the image, yeah? Look at the image. Okay, so the identity of Bn, right? Bn. We want it to be inside here, not here, yeah? Not outside. Okay, inside here. This is the one from the previous chapter. H is the subgroup of G if the identity of G is in H. Okay, right. The second one, if X, Y in N, okay, you remember our multiplication is we add, right? Because they are all codes. So all these words, X, Y, and so on, they're all zeros and ones, right? If you have like M equals 3, B3, that will be like 1, 1, 1, 1, 0, 1, 3 digits of zeros and ones. Okay, then the third one, if X is in N, then the inverse is also in N. This is symbol, yeah? This is a symbol for the inverse. Okay. Now, as an example, you remember this identity, close, inverse. If you want to show this first, it's okay, but this is following the notes. We should look at the identity, close, and then inverse. All right, look at the first example. Example, determine whether F from B2 to B4 forms a group. I had to give you the F, yeah? F of 0, 0 is 0, 0, 0, 0. F of 0, 1, 1, 0, 0, 1. You see, this is B2. B2 means 2, 2 to the 2. All right, it's always 2 to the M. How many possibilities, right? Because there are M of them, each one, there are M of them. And each one has 2 possibilities, right? Zeros or ones. So the possibility will be 2 times 2 times 2, 2 to the M. So I know that I will have 4 of them. If I start with this B3, there will be 8 of them, right? So how do you get this possibility? You start with 1, 0, right? And then 1, 0, 1, 0. So you get 1, 1, plus 1. 0, 0, 0, 1, 1, 0, 1. Oh, I start with 0 first. 0, 1. This is how you do in statistics, right? And probability, the number of possibilities. So M, because this is 2, and For each one, there's only zeros and ones. So you have 0, 0, 0, 1, 1, 0, 1, 1. This will be given, yeah? If we have B3, sorry, if we have B3, you still have just zeros and 1 as your choices, but you have 3 times, right? So you will have 8, yeah? 8. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Okay, so this one will be given, yeah? This one will be given 1, 1, 0, 1, 0, 1, 1, 0. So this is given. We want to see whether this forms a group code or not. Okay. All right, so we let n equal copy. Okay, and we want to see is n a subgroup of B4. Yeah, if it is a subgroup, then the answer would be yes. Okay. If in any time you have a question, you can just unmute and ask question. Okay, now the easiest way is to construct a Kelly table. Okay, if you are given a set, because to show that it's close or not, it's easy, right? To construct a Kelly table. So we do a Kelly table. You put in this. And right away, you will know that the E of B4 has to be all zeros, right? This is the only way that you want to add x plus the E is x. The only way is when when E is all zero. So that padam pula dah. The first number one is E, B, N in N, right? So the question or the N, the subset that you are given has to have 0, 0, 0, 0. So this is easy, right? Copy. Because they are copy, copy. Okay, now you have to add. And you know this is numbers. You only add. Okay, the second thing that you have to know is if you add 1 to 1, you get 0, right? If you add 0 to 0, you get 0. Meaning x plus x is equal to 0. E, I mean. 0 is E, right? Because 1 plus 1 is 0, 0 plus 0 is 0. So if you add x to itself, you will always get 0, right? So easy. Don't need to calculate. If you calculate, because it's the same thing, okay? You remember yesterday I gave you the rule, right? The rule 0, 1, 0, 1. This is 0, this is 1, this is 1, this is 0. So if you add the same number, you get 0. Okay, now you add. And you know X plus Y is Y plus X, because the numbers that you add, 0 plus 1 is 1 plus 0, right? So you only have to find these three, and then they match up, symmetry, yeah, because it's the same. Okay, so add these two, you get 0, the first, the second one, the third one, the last one. Okay, and then I just copy because it's the same thing. The first, second, the third, the last one. And this one, the first one, the second one, the third one, the last one. And then I just copy. Okay, and then the last one, add 1, 0, 1, 1. And then you add. And then you see, is it close? Yes or no? Yes or no? Is it close? Close means the numbers you see inside here, are they in here? Are they in here? Why not? Because, for example, this, right? Also this, right? And also all of them actually. Okay, which is actually this also, right? So the answer is, this is not close. Okay, and is not close since, okay, I will write, yeah, 1, 0, 0, 1, and, or just comma, 1, 0, 0, 1, and 1, 1, 0, 1 in N, but 1, 0, 0, 1 plus 1, 1, 0, 1. Okay, I take, hari ni kita main color-color. Just like that. Many new markers. Last day kau dapat marker. Okay, so I want to show using this one and this one to get this one. Yeah. Okay. So 1, 1, 0, 1. Sebelah ke pula? Ada color lain. 1, 0, 0, 1. Oh, hijau. 1, 1, 0, 1. Okay, they are in N, but when you add 0, 1, 0, 0. Tak 0, 1, 0, 0? No. Yeah, not in N. Okay, thus N is not a subgroup of B4. So read the question. Okay, so F does not form a group code. Don't forget to answer the question. Okay. Do I have to go to and find the inverse? No, right? Because already got one reason not to. If you ask about inverse, yeah, the inverse exists for this one. Because once the identity is there, right? It's always this means X is always the inverse for this particular one, right? Because this plus this, you got identity. this plus this identity, this plus this identity. So it's always the inverse of itself for this particular section, yeah? That's why what we check normally actually is the identity and close or not. So I repeat, you are given the N, you want to show whether it's a subgroup or not. To show it forms a group code, it has to be a subgroup. So we write out the elements in terms of rows and column to make a Kelly table. And then we add, so I just copy the first row because it's just zeros and the first column. And I always fill out the diagonal because x plus x is always all just zero. And then I will calculate this 3 and its symmetry. I just write and I got this 3. Don't need to calculate twice. And then I look inside the table, especially this 3, because the others is just copying, right? This 3, whether they are elements of here, you just need to choose one. You don't need to show all. So you can pick this one, or this one, or this one. Even for this one, they are the same thing, right? I can pick that too. So I just pick this one, this and that, to show that they are in N, but when you add, they're outside. Remember the circle? So it's outside. So it's not closed for N. Thus N is not a subgroup. So F does not form a group code. Okay. Now we want to do another one. Okay, another one with a different encoding function. Okay, for this one, any question? Is it okay? Okay, okay, okay. All right. Okay, Seni, okay? Yeah, okay. Because okay, I will. Right. Now I will give you another F. Okay, with the same question, but this one I want to do 2 to 5. 2 to 5. Okay, so I give you F of 0, 0 is 1, 2, 3, 4, 5. F of 0, 1. F of 1, 0. And F of 1, 1. Okay, so again, let N equal 1, 2, 3. You see, if you given any question, zeros has to be in there. If zeros are not in there, automatically it's not a group code because the identity is not in there. So you will see all questions, they have to include this 0, zeros. Copy. Yeah, 2 to the 2, there are 4 of them. And there are 1, 2, 3, 4, 5. Okay. We want to show B is a, determine whether we want to check whether this is in a subgroup of B5. Okay, now we do the Kelly table, yeah? Do the Kelly table. So we have 1, 2, 3, 4, 5. Okay. Kurang panjang. Okay. Then this is a plus. You know, I normally will double check when I copy the question from the question sheet, double check, because it has been so many years, students copy wrongly. If you copy wrongly, meaning you change the question, then all your answers gone. So, okay, copy, yeah? So I fill out this first, copy. Copy here. That's the first step. The second step, I fill out the diagonal. Okay. And the last one, I add. So I have only these three to add, and then I can fill out this. Okay. So the first one is 1. The second one is 1. The third one is 0, 1, 1. Okay, this one is 1. The second one is 0, 1, 0, 1. Then the third one, is 1 plus 1 is 0, 1, 1, 1, 0. Okay. And then you just copy to the one symmetry. Okay, so this is 1, 1, 0, 1, 1. Right? This one is supposed to be, even if you add one more time, you can do that to just double check. Okay, I double check when I sum up earlier, so you can double check now just to make sure that you get the same. 1, 0, 1, 0, 1, and last one 0, 1, 1, 1, 0. Okay, so then I will check the one in green. Yeah, the one in green, are they part of the element in N? Yes or no? You can type, or you can yes or no. Yes or no. Okay. 1, 1, 0, 1, 1, 1, 1. Oh, here. 1, 0, 1, 0, 1 here. 0, 1, 1, 1, 0 is here. All right. So in this case, we will say that for all x, y in B, for all x, y in N, x plus y is also in N, right? But you have to write all. Okay, this is the second one, right? So the first one you will write 0 of, E of B5, which is equal to 0, 0, 0, 0, 0 is in N. That is the first one. Yeah. E of B5, which is 0, 0, 0, 0, 0 is in N. Yes. The second one, take any two xy, you show that the sum is in N. Okay, which is shown from the Cayley table. So you just write this in general. You don't have to write one by one, because this is true for all. You don't write this for every detail. We have showed inside the table. And the third one, for all x in n, x inverse, which is equal to x, is actually in n. This also you write in, this one no need. It's okay. Okay, so this, if it is a group code, you will write this like this. It's a copy paste, right? This is just from the given definition, yeah? Because this is very general. So once your Kelly table is nice, it's a Kelly table, the reasoning is this. It's always this in general. So the first one is that the identity accordingly to the question, which is 0, 0, 0, 0 is in n, because you can easily see that this is the identity. The second one is quite hard to show that it's close. So you have to show that with the Kelly table. From the Kelly table, this is in. And the third one, the inverse, is just to write out that the inverse is x by itself, right? Because that will give you the 0. So that is what I give that. But I also write out that you can also write out the inverse if you want to. But if you just write in general, I will also accept that. In the notes, I put the inverse of this is this, 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 just for specifically. All right. Okay, thanks. Okay. Okay, so far? Okay, if it is not, it's quite easy, right? You just go straight to the second one. Okay, another thing is that if it is not, okay, you look first, you don't need to write the Kelly table. Just pick any two, okay, and try to add. Because you will be wasting. We don't need, right? Just now, when we want to show it is not a group code, we just take an example, right? So you're given a question, just take any two, try to add whether they are inside or not. If they are not, you straight away say it is not a group code because it's not closed. Take this and this, you add, it's not inside. No need to show the whole Kelly table. I'm just showing you because I want to explain how do you write the Kelly table. But if it is a group code, you need to show everything. That's why you need to have all in a Kelly table. Okay? So if you are given, after this, if we have time, we can go through some examples, yeah? Okay. Now the last part is about the decoding and error correction. Okay. Today we become like cryptologists or cryptanalysis or computer scientists that do decoding. Okay. This one is decoding. And error correction. Okay. Now, this decoding function, we require it to be onto. Okay, we want it to be onto. Let me see, question. Subgroup and group code, the same thing. Okay. A subgroup is a group. That is why you want to show something is a group code. If you show it's a subgroup, means it is a group. Okay, it's a good question, right? A subgroup is a group. All right, because not only it is a subset, but it is itself a group. So we call it a subgroup because there is something bigger. There is a bigger group G. Just now, we have N here, right? We have N here. We have B, N, right? Okay. This is actually a subgroup of a bigger group. This is everything. That's why it's a group, right? In the bigger one, everything is there, so it's closed and everything. We want to show it's a group code by itself, but this is actually a subset of a bigger one. You don't need to check on the associativity. So you just show this is a subgroup, automatically it becomes a group by itself. So to answer the question by Anonymous, are subgroup and group code the same thing? Actually, the answer cannot be yes, they are the same thing, but in a way, yes, because how can you say subgroup code and group code the same? This is a group code, this one, but this is not a subgroup code because there is no bigger one, right? This one is a group code, which is also a subgroup code because there's something bigger, which is a group. Okay, I hope you understand the difference, yeah? Okay. Now, make sure that the decoding function has to be 1, 2. We have this BM. We have this BN. There is an F. We want this to be onto, so anything in here can be decoded back. That is what it means by the decoding. So if there is something outside just now that is not mapped, then you cannot go back. Okay, I will show you in detail later what I mean by this. You have F from BM to BN. We call this encoding function. And so when we go back, P, call it P, from BN to BM, decoding function from N to M. Okay. Now what we will do is to use a technique called the maximum likelihood technique. Okay, we will use this technique to decode a function, maximum likelihood technique. Okay. Okay, I will write the procedure here. Okay, so suppose F from BM to BN is a group, meaning it's a group code, yeah? Okay, now the first step is step 1. Determine all left cosets of N, which is actually F of BM in BN. Okay, because just now, let me draw again. You have BM, you have BN, you have F. Everything from here, you have N. This is all goes to here, yeah? If you have a B here, you have FB here. Okay, so this is the whole thing goes to N. and this is in Bn. Okay. I will talk more about what you mean by coset. You remember from the last time we mentioned about the group, there is a coset. Step 2, for each coset, find a coset leader or representative of the coset. So this is a word of least weight. You remember the weight is the number of ones, right? Okay, step 3. If the word X is received, determine the coset of N to which X belongs. Okay, this is the receive X, and then you want to decode that. Step 4, let alpha be the coset leader. Okay, let alpha be the coset leader for the this coset, yeah. For the coset determined in step 3, compute X is xi plus alpha. If X is FB, we let D of xi is B. This xi, yeah? X has to have a B goes to X. That is, we decode xi as B. It doesn't really make sense, right? Because there's so many variables, cosets, but once we see it in example, I think it is much easier to understand this. Unfortunately, I don't have another big whiteboard to put example to show this and that, but we have the notes. I will read again this step when I'm explaining the next example. Okay, so remember the steps. Step 1, we will find all the left coset. I will show you step by step. Like if you remember, we add the take one representative, and then we write out, and whatever it is inside there, we cancel from the, and then take the next one and add until we cover the whole of the set. That is the coset. For each coset, we find a coset leader. So you will see a coset leader, and then whatever the X receive, we want to see which coset in our coset partition, and then we will compute this at the end. I will show you. All right. Easy to just screenshot, right? Okay. Okay. Now let's try and solve this with an example. Okay. Now suppose F is from B3 to B5. All right. I will give like differently from before. Before I put f of this is this, this one I will write like this. I will give you the x and then the f, yeah? So 0, 0, 0. You see, if I put B3, meaning I have to have 8. 2 to the 3, I have to have 8. So 0, 0, 0, remember? One, 2, 3, 4, 5, 6, 7, 8. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Push, buruk. Okay. I had to give you the F. The first F is, it has to be a subgroup, yeah? It has to be a subgroup. This is the prerequisite. 0, 0, 1, 1, 0. 0, 1, 0, 0, 1. 0, 1, 1, 1, 1. 1, 0, 0, 1, 1. 1, 0, 1, 0, 1. 1, 1, 0, 1, 0. 1, 1, 1, 0, 0. This will be given. Okay. This is not the whole of b to the 5. Remember, b to the 5 has how many elements? Type. B to the 5 has how many elements? Let me see if you get the right. Like b to the 3 has 8 elements. B to the 5 has how many elements? 32. Yeah? 2 to the 5. And you can list all 32, right? 2 to the 5 by doing this. 1, 2, 3, 4, and then another one. 1, 2, 3, 4, 5. For example, 0, right? 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. But I take only 8 of them. Out of that, 32. So you know how many cosets that we have. Remember the number of cosets is the how many over this, right? So this is actually, right, which is 4. Or you can just write 32 over 8. So we will have 4 cosets. This is already the first coset. Okay. This is from before, right? The number of elements in the big group divided by the element of the subgroup. Okay, so we have the number of coset. Okay, now first we want to find the coset, right? Now the representative of the first coset will be the least, the element with the least weight from n, because this is our n. So I write again the n. One, two, three, 4, 5, 6, 7, 8. This is this element is the least number of weight. It become the leader. It become the leader of the coset. Okay. Okay. Next one. Kenapalah saya asyik padam je let me do this again. Satu je lah tapi banyak sangat. Okay, I already get this one, yeah? I already get this one. Okay, and then this one you cancel out. The next one, the next leader for the coset will be the next element with the least weight. With the least weight. And there are a number of them. Least weight, what is the next number after 0? Ni bukan soalan trik lah, ni betul. What is the lowest number is 0, right? The weight, there is no ones here, so the weight is 0. What is the next number after 0? Ada orang ke tidak ni? Tak nampak siapa-siapa pun.
1.
1. Macam soalan trik ya ke soalan macam ni? What's the next number after 0? It's 1. So we have put a number, right? With 1. 0, 0, 0, 0, 1. This one, right? Or you can put this one, right? Or you can put this one, or you can put this one, or you can put we have 1, 2, 3, 4, 5. You can actually pick any one, but I normally will pick the one with the least value. You know, remember we learned this long time ago. The value here is actually 1. The value here is actually 2, 4, 8, 16. Right? If we look at the binary value. So I will start the lowest value. So I will take this one, yeah, with the least weight one. So that becomes my E2. 0, 0, 0, 0, 1 plus n. So you have to calculate, add 1 to all. Add 1 to all. You will see that you will, because they are not in here, don't pick the one that's here. But this one, the weight is 2, 2, 4, 3, 3, 3, 2, 3. If there is something in here with weight 1, don't pick that because it will give you the same coset. Yeah, but none of these are in here. You can pick actually any one, but I will pick this one. Add up. Add 1. So I just changed the last digit, yeah? I just changed the last digit. Okay. Next one. Okay, now I want to see E3. Okay, now I already have this, right? So this is picked already. And you see this? This is already in there, right? And nothing else. So I just take the next one, yeah? Okay, so now I take this one. So this is 0, 0, 0, 1, 0 plus n. No, don't add to this one, but you need to add to the first one. Okay, now you need to change the fourth one, yeah? The fourth one. So the fourth one, 0, 0, 0, 1, 0. The fourth one, 0, 0, 1, 0, 0. The fourth one, 0, 1, 0, 1, 1. The fourth one, 0, 1, 1, 0, 1. The fourth one, 1, 0, 0, 0, 1. The fourth one, 1, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0. I probably make a mistake, so please correct me. Yeah, you double check. All right, now you already have this one, this one. Now, see this? Okay, not this one, yeah? So this one is left. The only one left with weight 1. If there's somehow this inside here, now you have to choose weight 2. Okay, weight 2 will be 1, 1 here. Okay. Now the last one. So E4 is 1, 0, 0, 0, 0 plus n. Because 1 with 1 is none inside here. So add 1, the first one here. Add 1, first. Okay, you will see that this 32 are all of B5. Okay. So like I mentioned, the coset actually is a partition. Like you have one big cake, you divide into 4. So you have 32 of you in the class. We divide into 4 groups. Each group has 8 students inside. So this is how the coset works. Okay, now we want to write a Kelly table. Okay. But since they are already here nicely, this is actually my table. Okay. In my notes, I have this in the form of table. I'm not going to do it again, but I will add up the X on top. Okay. I will add up the X on top. But since they are already nice already, I will just do this. Yeah. This is the table that I have. Tak nak kacau ni eh. The table that I have is X, and then E1, E2, E3, E4. And the first column, the second column, the third, fourth, fifth, sixth, seventh, eighth column as in the table. Okay. Then the question, belum ada soalan lagi ni. Decode these words. This is the last step, yeah? Decode these words. So let me repeat the steps after I put this. Let me say again. Step 1, determine all left cosets. So this is all left cosets. The first one, the second one, the third one, the fourth one. For each coset, find a coset leader. So we already get all the coset leader. If the word is received, this is the word. Determine the coset to which X belong. Okay, so 0, 0, 0, 1, 0. Where is it? Cari, 0, 0, 0, 0, 1, 0, 0, 0. Huh, this is this, right? Okay, this one, it's this one, yeah? So this belongs to this first coset. Okay. Then you find the coset leader and you compute. Then you decode. Okay, that one is already done here. But let me just first find this one. You will write P of 0, 0, 0, 1, 0. Because this is in here, you decode back, you just take this. This is 0, 0, 0. That is your answer for decoding this word. I actually make a little shortcut that I don't have to calculate anything at all because it's straightforward to get the answer. The second one, P of 0, 1, 0, 0, 0. It's not part of this one. Which one? First, second, third. You see? Right? Okay, which is 0, 1, 0. So what you do is you find the word receive and decode back. You remember the P? The P is from B5 to B3. So what you will get is one of these. It's not in N. Okay. Normally the question here, they won't give in N. If in N, you know exactly it's the question. So trying to give something from all of this. Last one. P of 0, 0, 0, 1, 1. Here, right? 1, 0, 0. So this is the answer of decoding. Decoding it. I have like 1 or 2 other examples that you can go through because it's pretty straightforward. Yeah. And you can do all of the question in the exercise of coding theory. Okay. Actually, they all will be in the final, and you can, it's not that hard to score, just that you need to understand. But some students, they are not careful enough. When they do this, you pick something that is already in here. If you pick something that is already in here and do it again, or you do different calculation or wrong calculation, you won't be able to partition the 32 elements into 4 equally correctly subsets. Then that's one of the reasons why you cannot find some of the received word, right? If somehow you partition wrongly, you calculate wrongly, then they are not in here. Here, I have everything in here because I do this step by step accordingly. So the point here is the first one is always the one given because N in the question has to be a group or a subgroup code. That is probably they will ask you, given this N, given this function, encoding function, show N is a group. Then you have to do whatever we did before. Do the Cayley table, and the identity is there, is close, and then the inverse is the X. So you start with that. The second question, then maybe you have to find the cosets to do the decoding function. Then you start with writing up N, and then pick another leader for the next coset. And how do we pick just now? We go to the least weight, right? If you do by family tree, you don't need to, because it will take time. You don't need to list all 32. I didn't list all 32. Yeah, but I did and see from some of them, right? I list like just 5 of weight 1. If you have weight 1 already in all of them, you go to the weight 2, right? And then you go to the weight 3 and so forth. Then you make sure when you calculate, be very careful And remember that the basic table that you need to do when you're adding is the table I draw just now. When you have 0, 1, right? 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0. So what I do is I just do it in my head. I just focus on which component that I want to add to save time. If you do like the first time I show you, I said you can do it right like this, right? Then you can add like this. Then you can add like this. But this will take your time to copy and the rest. So you can just see the first one. You will change only the first one because the rest are all zeros. So you focus only on the first component. So I just add 1, change 1 only to the first component. This one, this one, this one. 1 goes to 0, 1 goes to 0, 1 goes to 0, 1 goes to. Okay. 1. Sebaik tak ada soalan dekat sini, right? This is 1, right? Betul lah, apa ni? 1 and 1. 1 goes to 0. Okay, 1 goes to 0. 1 goes to 0, 1 goes to 0. Okay. Yes. Okay. Okay, go to the question, yeah. Just to help you prepare, because I said when you are studying for your final, okay, then when you study for your final, you have to study first and don't wait for the review session. So you have questions to ask. Okay, go down, go given to state graph, turun ke bawah, soalan dia apa? Figure 1, figure 2, build a state table, yeah. Find the output and find the input for the machine. Ada yang figure 1, ada yang figure 2. Okay, this is quite straightforward. Next. Okay, you given this, terbalik pula, build a state graph. And then for M2, that is the machine, find the output sequence given the input. I give you, find the output given the input, but they have another question, give the input for the output. You try that yourself first, yeah. Number 3, you want to, they want you to check. Number 3, go down a little bit, that this is a homomorphism. Okay, they already give you, and build a state graph. Number 4, also to see it's a homomorphism. Number function, so you go from one to another with homomorphism G, like in the example. Okay, next. A, B, C. Okay, number 5, go down. This is the next. This is for the quotient machine. Okay, turun lagi.
Itu je, Prof.
Huh? Oh, in exercise 4. Okay, go back to the previous exercise. Construct a state graph. Okay, go to chapter 8. Ini dah e-learning. Dah boleh access e-learning. Yes. Okay, go down to the question. Student mungkin tak ni ya. Guess and TA boleh. Okay, find the weight. Alamak, kacang tengok je 1A, 3, 2, 3. Ha. Macam tu je. Number 2, you have to find the distance. So you have to add, right? And then find the weight. Number 3, like we did yesterday, find the minimum distance. And next, number 4, find the minimum distance and use the error, right? Number 5, just now in the first part, we put in the Kelly table and show it's a group code. And then the last one, determine the number of errors given the encoding function. Go down, number 9. You given all the encoding function this and decode the word. Yeah, using maximum likelihood decoding function. I think that's it.